Hello, geometry students. All right, so we are getting started on page 26. We're talking about area today, and this next foreseeable few days. So, shouldn't be too hard. This first page is just literally formulas. So, you may want to pause it, write down all this stuff, and then restart it when I start talking again, so that we can talk about each formula. Okay, welcome back after you paused it, I hope. So the first one we have is the area of a rectangle. And honestly, the area of a rectangle, area of a square, and area of a parallelogram is the same. It's the same formula, right? It's base times height. Literally, it's identical. You can see in the rectangle, the base is the part in the bottom, the height is the part going up. Multiply them together, that's your answer. Squares, same thing, base times height. But sometimes you'll see squares written as s squared, the side squared, because the side times itself, like 4 times 4 is 4 squared. Base times height, if the base and the height are equal, it's going to be side squared. So sometimes you'll see it written as side squared. It means the same thing, side squared, base times height. But I think learning a whole new formula just to do the same thing as base times height is silly. So I would only ever do base times height. Parallelogram is also base times height. The important thing about a parallelogram, though, is that the base is the part across the bottom. The height is not the diagonal part going up. No. The height has to go straight up. Heights always have to make a 90-degree angle wherever they're at. Wherever you're getting your height from has to be 90 degrees. So in this case, like in the picture, you can see the height is that dotted line. You may have to use Pythagorean theorem sometimes to find that. If they told you that the base was 10, and then that little part of the base was 3, and the hypotenuse was 5, well, or like that diagonal part's 5, you would have to do a squared is 3 squared plus b squared, which is the missing part, equals the hypotenuse 5 squared, which you would then solve and get 4 for your answer. Just as an example. And then you could do 4 times 10 to get your area. So just be mindful of that. If it gives you the diagonal, you've got to use Pythagorean theorem in some way to do it. Moving on, the trapezoid. It's the first formula that looks a little bit big and a little bit scary, but it's really easy too. It's the same as the other ones. It's base times height. The problem is, in a trapezoid, there's 2 bases. There's the base on top and the base on the bottom. Base 1, base 2. So what you're going to do is you're going to find the average of the 2 bases. Find the number in the middle of the base 1 and the base 2. So if you have 15 on top and 5 on the bottom, well, the number in between 15 and 5 is 10, which you could easily get by doing 15 plus 5 is 20. 20 divided by 2, 10. So you find the average of the 2 bases and then do average times height. Average base times height. So it's base times height still. Average base times height. Same thing, just make sure you do that extra step to find the middle number. Triangles, again, keeping that same, you notice all this kind of follows that same progression, base times height. But it's half the base times the height. And I can show you really quick, really easily, why that's true. Right? If I go right here, ooh, disregard that. We're not doing any of that craziness. If you look right here, here is a rectangle. We know rectangles are base times height. Well, look, that's a triangle. It's half of the base times the height. Take base times height, you get the entire rectangle. Take half of it, you get just the triangle. So triangles are just going to be base times height divided by 2. That's what that 1/2 means. Just divide it by 2 at the end. So that covers your basic ones. From there, we have a few other, I guess circles are kind of part of the basic ones too. We already learned circles though. Circles are pi r squared. Make sure you use the pi button unless instructed otherwise too. In terms of testing, it might say use 3.14 for pi. It might say leave it in terms of pi, which is where we don't actually multiply by pi, or we'll find the exact answer. You don't multiply by pi. So just make sure you're mindful of that. The other two that are a little bit strange is you have the triangle using trig. So if they give you a non-right triangle, so with a right triangle, it's easy. It's always 1/2 base times height. And I should have made a point in that triangle. Remember, the height has to be that dotted line going straight up and down. It's never the diagonals. The base is the flat, and then the height has to make a 90-degree off the base. So if they give you a triangle where they give you maybe 2 of the sides and then give you the angle in between those sides, so notice it's in that side angle side pattern. If they give you those things, you could use trigonometry to find your answer, which would be written as 1/2 little a little b, which are the 2 sides, times the sine of c. And if you work that out, you could see really easily where that comes from, right? It would really be that if you made a right triangle there, your hypotenuse would be a, and then your c would be the side, so you do sine of c equals the height over a, so you'd multiply a times the sine of c, and then multiplying by b as the base, and then times a half. So it's the same formula, it just looks a little bit weird. And the last one's the rhombus. If they give you a rhombus, you can take diagonal 1 times diagonal 2 and divide it by 2, and that will give you the area of the rhombus. So that covers all those. I should also say kites fit into the same thing as rhombus. If you want to find the area of a kite, same thing. Diagonal 1, diagonal 2, divide it by 2. Multiply them together. You have to memorize those formulas. That part's kind of a pain, is that you have to have those all memorized. They don't give them to you on any tests. So make some flashcards for all of those and practice them. Practice, 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 practice. Start by trying to look at the formula and tell yourself what shape it is. So look at the back of the card first. Okay, if I have base times height, it's a rectangle, square, or a parallelogram. If I have base 1 plus base 2 divided by 2 times height, it's a trapezoid. And then flip the cards and start looking at the shape. If you see the word triangle using trig, you have to know off the top of your head, oh, that's 1/2 AB times sine of big C. Practice that. If you practice that every day for a week, you'll have them down. Super important that you know that. Okay, so let's look at 2 examples. I have the examples worked out in my notebook like we normally do, and I'll put those up at the end of the video. But for now, we're going to use my little Wacom pad and do them together. So let's go over here to my little notepad. Boom, boom. So our first example. First example is to find the area of this triangle, and I purposely picked one of these sign examples just so we could see how to work it out together. I didn't put my notes in front of me like a fool, Mr. Nakarado. So I don't have the math in front of me. We'll figure it out. Okay, so I know that when I see this, it's not a right triangle, but they gave me a side, angle, side pattern, right? So I know that I'm going to use that area is equal to little a, little b, times the sine. What am I doing? What am I doing, guys? Delete. Okay. Try that again. Area is equal to 1/2 little a, little b, sine of big C. That's what I was looking to do. So my 1/2, a is going to be 6, b is going to be 12, and c is 42, so sine of 42. You can see how nice that is to put in your calculator, right? You would just type that all in. 1/2 of 6 is going to be 3. 3 times 12 is 36. And in a calculator, we take 36 and multiply it by the sine of 42. Pull out my calculator here. So making sure my calculator's in degrees, it is 42 sine gives me 0.669130, blah, 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 blah. Leaving that in my calculator, I'm going to go times 36, and I get 24.088. 24.088, and I didn't say what to round to, so let's round to hundredths. If I don't say what to round to, just usually assume it's that. So 24.09. And we got to make sure we put our units on here. Since we're talking about area, we're going to use inches squared, and that would be the area of that triangle. Pretty simple, yeah? Okay, so we have a second example. And in this one, I have this little shape here that kind of is weird looking. Like, it doesn't look like any of our shapes that we have. And they want the exact answer. So you got to be careful that if they give you something like this, they're clearly looking at a circle, but they took that circle and they cut it in half and got rid of the bottom part, right? So if you got rid of that bottom part, I didn't grab the whole thing. Got rid of this bottom part right here. Boop. Boop. Oh, that got rid of the whole thing. It's okay. You get the point. I'm going to draw the actual just circle then. It's just this top part right here, just the half of the circle. Well, we know the formula for area of a circle is area equals pi r squared. Now that gives me the whole circle though. That's going to give me this part down here as well that I don't need. So if we're going to take that and make it just part of the circle, well, we're just going to multiply it by a half, or at the end divide by 2. Getting rid of that extra half, or getting rid of the extra half from there. I know that I need to plug in r, and this gave me 14, but 14 doesn't represent the radius. 14 represents the diameter. So if we're going to turn that diameter into a radius, remember, we take the diameter and divide it by 2. So if I divide 14 by 2, I get 7. So I know the radius is equal to 7, and that's what I'll plug in over here. So I'm going to have 1/2 pi 7 squared. Go ahead and multiply that 7 squared, and I get 49. Now notice they did say give me the exact answer, which means we're not going to multiply by pi. And I also don't want any decimals. So I know it would be really easy here to take 49 divided by 2, get that 24.5, and be like, oh, 24.5 pi. No. You're not allowed to have a decimal in front of pi for an exact answer. You can't have a decimal in exact answers because then the person doesn't know if you rounded that decimal or not. You have to leave everything in fractions and pies, right? So I'm going to take this 49 times 1/2. Well, we multiply 49 by 1, and we get 49, and put the 2 underneath it, right? 49 halves. That's 49 divided by 2. And then we take that pi and put it on top, and that's going to be the exact answer, 49 pi over 2. That's our area, and again, we got to put our units. Units are in feet squared, so I have 49 pi over 2 feet squared. So I know that only covers a couple of our examples. There's lots of different ones there. To me, to do every single example would be a lot of time, and you probably would just be annoyed with me if I did all those examples. Oh, look, I put the rounded answer on there too. I put both answers. So if you did round it, you would get 153.94. Just to... Mr. Nakarada screwed up those notes, didn't he? That's not right, because that's the area of a circle. I forgot to divide by 2, so make sure that with that, if you're copying that down now, you take that 49 pi and divide it by 2 to get the right answer, which means my rounded answer is also off. We would also have to take that and divide by 2, and you get 76 point something, right? 77 point something. Make sure you put that in there so that you have the correct answer. Your IXL should cover a lot more of these this week to kind of help you out. So if you do need some specific examples, like how to do maybe trapezoids, that can be a little bit tougher, or rhombi, go ahead and send me a message, and I'll help you out with those. But that should hopefully give you a good idea of the tougher ones. All right, good luck. Bye.